July. So in the last class we studied about elasticity. Today I am starting a new topic. The title is Production and Cost. It is from chapter number 3 of your NCERT book and will cover 10 marks as a whole. So as an overview, what I am giving you an overview of the chapter. In earlier chapter we studied about consumer behavior. Under consumer behavior we have an objective. The objective was simply to maximize utility given your budget constraint. That is the utility maximization is the objective as a consumer. Now what will be the objective of producer? That is what we will be studying. Now over here first we will be studying briefly we will be studying about production process, and then we will be studying about factors of production and what will be the objective of producer. We will also look at the concept called production function, and then we will be looking at what is total product, marginal product and average product. So that is what we will be doing. Now we know that as a producer firstly there is something called production process. Now production processes in simple terms is the entire process through which you will convert inputs into output. Output is the final product. Over here firstly the role is of factors of production, FOP, which is like factors of production. Now these are the agents which are generally used in this production process where you convert input into output. We have certain factors. First is land. The second one is labor. Third is capital. And the fourth is producer. Or we also use the term entrepreneur for this. What is land? Land is basically all those resources that we directly bestow from nature. It could be land, it could be any kind of natural resources. And labor. Labor is the physical toil that we use of an individual. Capital are all those raw materials or machines that we use in the production process. And producer is the person who undertakes the risk. He is the person who will use land, who will hire labor and use capital so that this production process can be undertaken. And also we have certain returns to everyone. For example, for land we use the term rent. So it is the return that land will get. It could be your land or it could be any kind of natural resource. For labor you will be getting wage. Capital you will be getting interest. Again, capital is further divided into certain categories. For example, we have physical capital, which are machines. It could be tractor. Suppose you are sowing a seed, you might be using some machines. So in return, you will be giving interest. It could be also financial capital or monetary capital. You will ask for some loan from bank so that your production can be carried. You will be getting interest. And similarly, we also have a human capital, which is investment in human. The third is producer. The return of producer is profit. Profit is basically the difference between total revenue minus total cost. The difference between this is what we call profit. Total revenue is whatever you finally produce and whatever you get it is total revenue. In the last class, we have studied that your total revenue is simply a multiple of price into quantity. Now what is cost? Cost is all those costs that you carry. For example, cost of labor, cost of land, cost of capital. That is the cost. So that is what we call factors of production. Now in this production process, simply at a higher level we see that a producer will undertake some kind of production by utilizing land, labor and capital. There's an element of risk also that he is undertaking, for which he is getting profit in return. After production, he will simply sell that particular product in the market by some other channels, and he will be generating some sort of revenue, which is what total revenue. Now out of this total revenue, he will be paying two factors of production, and the difference between this is what we call the profit. That is the return to the entrepreneur or the producer. So the next subtopic is production function. Now, production function, the definition is that it represents the maximum amount of output that can be produced by given input, assuming that your technology is constant. That is the definition of production function. Or, in other words, it's a mathematical relationship between input and output. Mathematically, you can symbolize production function where y is your output. It's a function of factors like x1 and x2. We have studied that there are certain factors like land, labor, capital and entrepreneur. For simplicity, we are using x1 and x2. That is the factors of production. So what it represents, how much the maximum output that can be produced by x1 using x1 and x2. A mathematical example could be, suppose you have an equation y will be given by 5k 1/2 L 1/2. 1/2 means the root of k and root of L. Here k represents your capital and L represents labor. So this is an example of production function. We can solve it. Suppose your k is given. Say k is equal to 100. You have 100 units, you are employing 100 units of capital, and also say you are employing 100 units of labor. Now, through production function, we will be looking at how much will be the output. You can simply put the value over here. Now what is the value? Simply I'm putting y is equal to 5, k is equal to 100, and also L is equal to 100, root of 100. Or y is simply 5, I can also write 10 square, and also here 10 square. So this and this cancels, this and this cancel. So as a whole, we are producing 500 units of output. So that is what the production function does. This is a simple example that we are using. Now, under production theory, generally we use the time period to determine what will be the process. So we have long run production function and we have short run production function. While producing a quantity, a firm or a producer have certain kind of rigidities. Some inputs could be fixed and some inputs could be variable, or you can say it's quite flexible. For instance, suppose I am a producer and I am employing a certain amount of labor and machine, and it will be some that will be my input, and I am also using land as a space. So in a short run, I can easily increase my production by employing new labor or by increasing working hours, but the size of your factory is limited. So there are some constraints which is limited. That's why we have a short run production function, or we can say short run production function. in short run production function, we generally assume that some of the inputs are fixed and some are variable. Over here, we can only increase your input by employing more of x1, which is your variable factor, while x2 is constant. But in the long run means is in a substantial amount of period, I can also build a new factory or use new land. So in the long run, I am not having this kind of constant. This is the constant. So in the long run, LRF, I'm simply representing long run production function. You have such kind of production function, x1, x2. Over here, both of your inputs are variable. You can easily increase the size of your factory. You can also employ more labor. So you are completely independent in the long run. While in the short run, you can only increase your variable factor, say labor, but you can't increase the size of your plant as a whole. Now the second concept related to production function is your isocons. Now again in your chapter first, you have studied a concept called indifference curve, which is very much similar to this concept isocont. So as a recap, we know that indifference curve is the set of all possible consumption bundles that gives same level of satisfaction or utility to a consumer. That is what indifference curve determined. So similarly, we also use the concept called isocont. The definition of isocont could be set of all different factors. Factors could be land or labor. I'm simply using x1 and x2, sorry, factor 1 and factor 2, that will give you same level of output. Similarly, similar again to your indifference curve, this is your isocont. So isocont also has certain amount of property. For example, first, it is downward sloping. Your indifference curve is also downward sloping. Downward sloping means, since keeping your output constant, if you are using an additional amount of factor 1, you might be sacrificing factor 2. That's why it is negatively sloped. Second, it is convex to origin, which is also the property of your indifference curve. And then third, higher isoconts will represent higher amount of production. For here, like Q naught will be representing all those possible combinations of different factors that will be giving you Q naught output. It will be higher than your Q1, and similarly Q2 will be higher than Q naught. That means higher the isoconts, higher will be the production, or higher will be the output. That is the concept of isocont. Isocont is also very important. Now as far as slope of isocont is concerned, again, in case of indifference curve, we use the concept called marginal rate of substitution to determine the slope of indifference curve. Here we are using a concept called marginal rate of technical substitution to measure the slope of isocont, which represents how much will be the change in factor 2 if you are employing an additional unit of factor 1 such that your output is constant. So the next subtopic is about total product, average product, and marginal product. Now these concepts are largely related to your short run production function. Now first is total product. What is total product? Basically, if you look to this particular chart that I am using, there's an equation for your total product. Hereby your total product is simply, what does it means? It shows the relationship. Relationship again means how much relationship of variable input with total output. That is what your total product. Or in simple terms, you can also say the amount of output that you are producing, given your variable product while keeping your x2 constant, which is your fixed product. Second concept is your average product. Average product is simply the ratio of total product to your variable product. That is simply Q to X1. The third concept is marginal product. Marginal represents how much will be the additional change in your output, delta Q, if you are increasing your variable product by 1 unit. That is what delta X divided by delta X1. For example, this is the change. This is output at X unit of variable product, subtracting output at X minus 1 unit of variable product. So that is what your marginal product. We can use this particular table. It represents how it is calculated. Again, it is very important from your exam point of view. Now here I am only using factor 1, which is your variable product. Different combinations of factor 1, 0, 1, 2, 3, 4, 5. So this is your variable product. If your variable product is 0, your output will be also eventually 0. For example, if it is like you are having a machine but you are not having a labor to operate it. So it's like 0 output. Now I am using 1 labor. So 1 labor, how much will be his production? His contribution will be 10. So total production is now 10. Now second thing is your marginal product. Marginal production means how much is the contribution of this additional variable factor. So it is simply, here I done subtraction. As per the formula, it's 10 minus 0. So it is 10. Now third is average. Average, total production divided by total product divided by number of factors. Since here total product is 10 and number of factor is 1, so we are getting AP1 is also here 10. Now I am employing an additional variable factor. So your variable factor is now 2. The total production is 24. Now I want to calculate how much is the contribution of this additional factor. So what is his contribution? I am simply subtracting 24 minus 10. So 24 minus 10 is 14. So that is the marginal contribution of this particular variable factor. Now average product, or you can say average productivity. We also use the term average productivity, and here marginal productivity also. So what will be the average productivity? Total product divided by number of your variable factor. So it is 24 divided by 2, 12. Now accordingly we are getting the chart. For example, here 40 minus 24, that is 16. Average product is simply 40 divided by 3, which comes 13.33. 50 for 4, so marginal product is simply 50 minus 40, that is equal to 10. Average product is simply 50 divided by 4, and so forth. We can get this particular thing. You can also use an example. Generally we have certain kinds of example in the exam where you will be given either total product and you need to calculate marginal product, or some of this variable will be given and you have to calculate it. So I am taking an example. In this example you have to calculate marginal product of L represents labor and average productivity of labor. So here variable factor is labor. Now here your labor and total productivity of labor is given, and you have to calculate the other two variables. For instance, when your labor is 0, output is 0. When labor is 1, 15. When labor is 2, your output is 35. When labor is 3, it's 50. And when labor is 4, it's 60. And finally, when your labor is 5 unit, it's 68. Now first we have to calculate marginal productivity of labor. So it's simple. In the first case, it's 0. In the second case, what will be the marginal contribution of first labor? It's simply TP1 minus TP0. That is 15 minus 0. It's 15. Now in the second case, what is the marginal production of second labor? 35 minus 15, which is 20. For the third, it's simply 50 minus 35, which is 15. And the fourth, it is 60 minus 50, which is 10. And finally, the marginal productivity of the fifth unit of labor is 68 minus 60, which is 8. So this is how you can calculate your marginal productivity of labor. Now what is your average productivity of labor? Simply as per the formula, it's total product divided by x1. Now here x1 is your labor. So in place of x1 you have labor. So in the first case it's 0. In the second case, what is your TPL? 15 and labor 1. So it's simply 15 divided by 1. The value is 15. For the second, it's 35 divided by 2. You can calculate it. And for the third, it is simply 50 divided by 3. Fourth, it is 60 divided by 4. And for the final one, it's 68 divided by 5. If you solve all this, you will get the APL. So lastly, we will be giving a brief introduction to two important laws, which is laws of diminishing marginal productivity of labor and law of variable proportion. These are the two laws which is used to determine your short-run production. Now what does the first law states is that your marginal productivity of labor, the marginal productivity that we just did, initially it will increase at increasing rate, but beyond some point it will start diminishing, and then it will becomes, eventually it will diminish, and eventually it could also become negative. That is what law of diminishing marginal productivity states. And the reason again why generally in the exam you will say you might be having question, what will be the reason behind diminishing marginal productivity? You can state that it is because of law of variable proportion. Now to understand it in a simple term, we can take the case of a field. Example of a field. Suppose you are given with a particular field. So initially, again your capital, here again since we are talking about short run, so your capital, whatever machines or whatever plug you have, it's fixed. So initially when you have one labor, he can easily, like using a machine, he will be producing something, he or that particular agent. Now when you have second labor, second unit and additional unit of labor, there will be a better coordination. A particular factor will be given in first task, and the second will be given the second task. Now when you have the third unit, again this coordination or specialization will increase. But eventually what happens is that when you keep on increasing your variable factor, keeping your field, the size of your field is fixed. So what the additional contribution of the labor eventually will start diminishing. That is just in our local language we use the term lashak. So it is simply like he will be like a source of lashak for it. Now the reason behind is that variable proportion, because with respect to your fixed factor, your variable factor is changing. So initially it will be more suitable. You will be having better coordination, better division of work will be there. So marginal productivity will increase. But beyond some time, your factor production will be not conductive. It's because you have fixed amount of machine, but now you are having more and more labor. So the additional contribution of labor, he will be just staying idle because the machine is fixed. So his contribution will eventually diminish. So that is the reason behind law of diminishing marginal product. So in our next class, we will study it in a very great detail. That's all for today. Thank you, Julian.